Yes. Who did? Jaden, be nice. You seem to be missing some people.
That's because they're late. Lego late. Where should I be? Lego late. Not everybody likes that.
Yeah, it was a bit too long, wasn't it? Yeah, let's just give you like
Water bottle.
Yeah, it was the 40.
If I could do the 40 by the end of the day and
Check. Yeah.
And I'll take the piece with Mr. Great Man. Great.
All right, give me a yes or no. Hot lunch. Elijah. Kira. Gavin. Vea.
Yes, please.
Matt. Malachi. Elizabeth. Lily.
Yeah.
Keegan. No. Yes or no?
Yes.
Bo. Bo. Nick. Jaden. Ace, not here. Pierce. Jameson. Abby, not here. Ben. Felicity. Jasmine. Bree. Caden. All right. Let's please stand for the pledge. I pledge allegiance of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. All right, find your seats, get out your homework. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12. I'll put 13 just in case Ace shows up. Sure. Okay, now teacher stuff's done. Questions on the homework? Yes, it was a lot.
No, it was not.
But it was repetitive in the sense of the pattern was kind of easy to identify and follow. Yes. You can, absolutely. If not, take a look at during student advisement. If you don't understand it, then I'll be around to help you. Okay. All right, any questions on the homework? All right, I'm not going to grade every bit of it. I'm going to call out the A of every one. You know, there was an A, B, and C. I'm going to call out A of every one. All right, here we go. Number, where are we at? Okay, here. Two. I'm just calling out A. 123,000. Number 4, 610,000. Number 6, 56,790. Number 8, 1.7, 1 7/10. Number 10, 369.5 or 369 5/10. Number 12, 210 8/10. Number 14, 5 1600ths, 5.16. Number 16 is 13. Number 18 is 0.903 or 903 thousandths. Number 20, 0.0014 or 14 10,000ths. Number 22, 34,000. Number 24, 16 and 2800ths, 16.1 or 28. Number is always 40. 30 is 4.26 times 10 to the 8th. Where is 32? 32, where art thou?
No, you skipped 26 and 28.
Oh, I said skip 26, 28?
No, you skipped. You just skipped.
I just skipped? Okay. 26 is 1.123 times 10 to the 4th. 28 is 3.8 times 10 to the 7th. 30 is, as the aforementioned, 4.26 times 10 to the 8th. 32 is 1.079 times 10 to the 11th. 34 is 3.57 times 10 to the 6th. 36 is 1.439 times 10 to the 10th. 38 is, where are you at? Oh, good Lord, look at this one. 7.0, well, we'll just call it 7 times 10 to the 7th. The one thing that I didn't mention, and I didn't want to get too complicated in scientific notation, is that there'll be a lot of rounding involved in scientific notation. So they wouldn't really write all those numbers. If you put 7.0797133, yeah, that's technically what you should have put. But most scientists would round that to just 7 times 10 to the 7th. And the last one, 1.544 times 10 to the 8th. Yes?
So you said like you're just going over A?
I just went over it, right?
Alright, if you like got that wrong, would you mark off the whole problem for that, or would it just be
You can. I mean, I'll understand because we only check part A. Yeah. Write the given number in scientific notation is all they really ask. But I like it. I like your idea right there. Okay. Yes.
What was 2?
Number 2 was where are you? 2? 123,000. You got what? I think you looked at the wrong problem because number 1 and number 3 are both close to 52. Number 2 is 240. Where am I looking at? I'm sorry. Yeah, number 1 is 52. You just looked at the wrong problem when you copied it up. Happens all the time. All right, make sure your names are on them. Hey, did I mention yesterday? I'm just getting lots of people not putting their names on stuff. I don't, investigate after the second or third week. Hey, we're way past that. I don't investigate. I just put no name on it, put a 0 in the grade book, and it's up to you to check and make sure that you don't have zeros in the grade book when you know you turned your homework in. So it is on you to check Power School to see if, wait, you gave me a 0? I know I did my homework. Well, it's probably sitting over here without your name on it, and that's going to be up to you. So that usually grows, and even though I ask students to do it, many don't do it. All right, where are we at?
Flexing and passing out.
Well, we'll see. We'll see. We'll see. All right, homework. We got no quizzes or tests the rest of the week. Homework is 1 through 20 all. Do not use a calculator. You want to use a calculator, check your answer after you're done, absolutely. But do not use a calculator to get to an answer for this.
But that's going to be technically impossible.
I'm pretty sure you'll be able to do this.
Yeah, maybe.
Now remember, the odd answers are in the back of the book, so you can check that as well too. The evens are not.
Are they gonna be a long problem?
Yes.
No.
This is an hour's worth of homework, but this is some homework here. Like, no joke, this is, solid 30 minutes of homework. Solid 30 minutes of homework.
So for me, it's only about 13 hours.
No, it's not going to be 13 hours.
I probably have the entirety of student advisement.
Yeah, student advisement, you can get this whole thing done in student advisement, absolutely. Some of you are going to look at this material, and when I tell you, and you can take the jack off too. And then when I tell you, hey, if you're 100% confident you know what you're doing, get started on your homework, some of you are going to get it done in class. Others of you need this class. I implore you, don't put yourself in the category of, oh yeah, I already know how to do this. I don't need to listen today. Don't put yourself in that category unless you are 100% sure. Okay? But yeah, there's going to be some of you that are 100% sure that you know what you're doing. All right, there are a few classes that me as a math teacher that I don't necessarily enjoy. This is one of them, right? I don't really, this isn't part of a 7th grade curriculum, teaching how to multiply with decimals. Yet, I have to deal with the fact that many of my students still can't do this correctly. So, although I don't like teaching the class, I still teach it. There's no one in here that hasn't had this class before. No one. All of you have had this class before. Some of you are great at this, better than me, right? Others of you struggle at this. So I've made this class for the kids that struggle. We're going to do this one at a time. We'll spend as much time as it takes in detail trying to fix our errors of the past, trying to, I don't know, reacquaint ourselves with the procedures of the algorithm of how to multiply decimals. If you're one of those kids that are sitting here right now and you're like, what, multiply decimals? I know how to do that. That's easy. And, right, you know, you can say with 100% certainty that you don't make mistakes, then yeah, you just saw what your homework is. Open up your book, do your homework. It's just 20 problems of practice. But if you're one of those kids who are like, yep, multiplying decimals, I make mistakes all the time, then this class is for you. Yeah. I thought I made that. Did I not make that clear?
Yes.
Okay. Put it in 7th grade language instead of a old guy teacher, math teacher language. Somebody, please. What I just said.
Basically, we can all do this.
You can do your
If
homework.
you get
If you're good at this and you know you don't need this lesson, absolutely open up your book, get started on your homework. All right. However, this class is specifically, and I teach it every year. I don't like blow it off. I'm going to teach it along with decimal long division the day after tomorrow, right? Which I think typically is where most kids, 7th graders, still struggle at. However, multiplication with decimals, most kids know how to do this, and they can teach it to someone else. That's always my thing. I'm saying, hey, if you know this, you should be able to teach it to someone. Okay? If you're that confident, then yeah, open up your book and start on your homework. But you need to be quiet so that I can help everyone else. All right, for the rest of us, we're going to talk about the procedures. Okay? If you can multiply those two numbers together and you know that you're not going to make a mistake, you should be doing your homework. All right. So, who can do this right now without making mistakes? You should be doing your homework. Yeah. Yes. Yeah, okay, then you should be doing your homework, right? But there's plenty of people in here right now that look at that and are like, yeah, that's where I kind of make my mistakes. What's up? What page is it?
89.
It's on 87.
All right, Gavin? They're not lined up. So, Gavin, this class is for you, buddy, right? So, if you have a question like Gavin, which is the decimals aren't lined up, then this class is for you because you don't know how to multiply with decimals. Yes? No estimation. I want you to multiply those suckers. Yeah. Absolutely. Okay. So Gavin, box number 1. Notice that the and others, not just Gavin. Notice that the steps are there in great detail. Right? I will show you step by step by step by step. Gavin, when we add and subtract, do you line up the decimals? Absolutely 100%. We line up the decimals. That's the only time we ever line up decimals. Only when you're adding, subtracting. When you're multiplying or dividing, we do not line up decimals. Okay. So I'm not going to read the steps right now, but I will go over them one by one as we do a problem. Yes. Oh, you got to listen. I said, just give me the answer. Okay. So practice, practice, practice. I got plenty of them. I got more than we need for today. We're going to practice until you're like, enough, Mr. C, I got this. You can stop and I can do my homework. Okay? All right, here we go. Well, that's clearly in the way. So one of the things is that sometimes multiplication is presented from left to right. And that's great when it's 2 times 3, because I can multiply 2 times 3 when it's written left to right. However, I can't multiply 14.92 times 7.2 in my head I don't have that memorized. And it's written left to right. Well, we don't have a method of multiplying from left to right other than memorize. So we switch to an alternate method. It's called the stacking method. Sound familiar?
Yes.
We're going to stack the numbers. However, we are doing multiplying. You can only multiply two numbers at once. So you have a choice. You can put the first one on the top or the second one on the top. Multiplication is commutative, right? First number times the second number is the same as the second number times the first number. It's your choice. So Gavin, what do you think the smart choice is for this one? Which number should go on top?
7 and 2 tenths on the bottom.
Okay, you said opposite of what I was expecting, but yes, when we stack, step number 1 says, put the number with the most digits on top. This is not a requirement. This just makes your life easier. We could certainly put 7.2 on the top. You wind up with this really ugly, ugly, ugly multiple step problem. However, if we put the one with the most digits on top, our life is slightly easier. So digits, I'm talking about literally from left to right. 14.92 has 1, 2, 3, 4 digits, and 7.2 has 2 digits. So we put the one with 4 digits on the top. We do not line up the decimal places. We put the second one on the bottom. Oh, I'm sorry. Graph paper. Once again, just like addition and subtraction, graph paper will make your life a whole lot easier when you do this. I will give you one sheet of graph paper. Who wants one? I'm just going to say graph paper lines things up perfectly. For those of you like me with sloppy handwriting, will make your life easier doing this with graph paper. No one? Okay. Gavin, use some graph paper. You're gonna like it. You're gonna like it. Trust me.
I was gonna say I can get some of my own out of my locker.
Well, I was giving you some. Merry Christmas. Okay. Notice, however, I did line things up slightly. It's not a requirement to do the multiplication to have anything lined up in the first step with the one that we're on right now. Just put one on top of the other. It's not a requirement, but it certainly makes your life a little bit easier. So we what's called justify. That just means lining up. We justify things right. Have you ever noticed in Microsoft Word, they have a little button that you can make all the text line up to the right, or you can make all the text line up to the left. This is called right justification. All right, so we line them up. Any questions on how we line them up? Then we go through our multiplication procedure. Yes, I will insult your intelligence. The correct procedure is this, and occasionally I get kids in class that have some, I don't know where they were taught, they have some different method of doing this. Some kids actually have a different method and it's correct. Other times kids have a different method and it's incorrect. I don't want to say the approved, the best, right? But the method that most people do is this. They go to the second number, the number on the bottom, to the digit on the far right, in this case the 2, and they go from not left to right, they go from right to left in the multiplication procedures. So they say 2 times the first number on top times its 2. So 1 place times the 1's place. I'm sorry, in this case, the 10ths place times the 100ths place. Okay? Boy, you can confuse yourself if you start talking place values.
Yes.
So basically what we're going to say is ignore the decimals. Don't even think about them until the very last step. We're just going to do multiplying. Gavin, 2 times 2?
4.
We write a 4. Now, with graph paper, this is where you want one number in every box. This is where you must line things up. 2 times 9?
2 times 18.
We don't write an 18. Occasionally I'll see some kids write an 18. We write an 8 and we carry a 1. We don't carry a 1 to the 9, we carry a 1 to the 4. And we continue the process. 2 times 4 is, plus the 1 that you carried is,
9.
and we write a 9. You're doing this in graph paper, everything lines up perfectly. And lastly, 2 times 1 is 2, and we're done with the 2's. Every time you continue this procedure and you drop down a line, you must add, somebody help me.
A 0.
You must add a 0. When we go to the second line, I'm sorry, the third line, we add
0.
2
2 zeros. When we go to the fourth line, we add,
4, 5, 6, 7.
well, the second line you add 1 0. The third line, you add 2 zeros. The fourth line, you add 3 zeros, so forth and so on. The zeros, if you have sloppy handwriting or you're not using graph paper, are where you get your problems. Some people, their zeros are really skinny, and then all of a sudden the numbers don't line up. When we do the second row of multiplication, the numbers need to line up. So I'm going to add my 0. Oh, notice what I just did in PowerPoint. I erased my carry. You guys can't do that. On your paper, you're going to have that 1 hanging out right there. And it's going to get in the way. So what do?
Cross it out.
Some people like crossing it out. I can live with that. The issue with crossing out is that if you were checking your work, you just crossed out what you need to keep. Right thing? I'm not saying don't cross out. I'm just saying you just got to be careful. And also, crossing out makes it even messier. Right? Also, think about if there's crossing out involved, you need extra space above it. So sometimes when you set the problem up, you don't give yourself enough space. Okay. So for the magic of PowerPoint, I can make my carries go away and have a nice fresh sheet of paper. So I add my zeros. Second row, we add 1 0. Third row, 2 0. Fourth row, 3 0. Hopefully you don't get to a fifth row. That'd be painful.
That'd be traumatizing.
Well, agreed, right? And I'm not going to give you something, you know, with 5. But this is fair game right here. Fourth the test. You know, a 4-digit times a 2-digit, that's fair game. We continue the process now, not with the 2, but with the 7 of the second number. Once again, I don't care about where the decimals are yet. I'm ignoring the decimal places. If we're doing adding, subtracting, that second step is you drop the decimal straight down. With multiply, we don't mess with the decimal until the last step. All right, 7 times 2 is?
14.
So I put a 4 and I carry a 1. Once again, you probably have some scratch outs. The carrying stuff can get in the way, right? Hand sanitizer.
I just got my 1.
7 times 9 is 63, plus 1 is 64. 4 carrying 6. 7 times 4 is 28, plus 6 is, oh, we're in problem land, right? This is a lot of math.
What?
7 times 4 is 28, plus 6 is 34. So 4 carrier 3. Once again, I made my first carry go away, so mine looks nice and neat. Yours will not. You're going to have numbers all over the place. 7 times 1 is 7, plus 3 is 10, and we're done with that step. Everyone knows you draw a horizontal line, and then we add. Once again, I'm not messing with the decimal. Do not drop the decimal straight down. That's not what you do with multiplication. That's what you do with adding and subtracting. Now I simply add, and here's the next problem. What's the problem when you add? What's the problem when we add?
You have to carry.
We might have to carry. So where do we put a carry? There's no space. Oh, sure there is. I'm just going to squeeze it in between the numbers, and that's where you get into issues. You got to be neat, which is why I'm doing it in PowerPoint, and I'm not trying to do it by hand. You'd be shocked at how horrible my handwriting is. So whenever I was asked to do this, boy, did I slow down. I forced myself to write very slowly and neatly. And when I did any carrying, I was very careful. So let's add. 0 plus 4 is 4. Oh, and we're doing it from right to left, not left to right. 0 plus 4 is 4. 4 plus 8 is 12. So I put a 2 carry 1. There's no space to put your carry. So what does everybody do? They squeeze it in right there, and they're like, oh, I'll remember. Right? It's troublesome, this carrying thing. 4 plus 9 is 13, plus 1 is 14. 4 carry another 1. The issue is some people now it looks like a 12, right? It's not a 12, it's a 2 with a 1 carry. The carrying thing can get you into problems. 2 plus 4 is 6, plus 1 is 7. There's nothing to add to the 0, but it sure looks like we're adding 1 with the carry, right? Have I made it clear that the carrying thing can get you into problems?
Yes.
I mean, it's the correct thing to do, the carry. But boy, the notation of it can cause problems.
Wait, you could add the carry in a different color. Just have
You cannot add the carry in a different column, no.
Well, I'm saying.
Oh,
like,
in a different color?
yeah.
I
you
like
have-
that.
Like you have just like your
I
normal.
like that.
The carries are like.
Right?
blue or
For those of you that want to put that effort in, then you have a colored pencil, and all your carries are in red or blue or something, so you don't make a mistake. 0, there's nothing to add it to, so it's 0. There's nothing to add to 1. Now we can mess with our decimal. The way you do your decimal is you go back to the 2 original numbers, and you count how many original decimal places in total. Not for each one, but in total. let's see, a 7.2 has one decimal, the 2. The 14.92 has 2 decimal places, the 9 and the 2. So altogether, the 9, the 2, and the 2 is 3 decimal places. We go from right to left, and we move it 3 decimal places. 1, 2, 3. And I'm already tired, and we've only done one problem. How many did I give you tonight for homework?
20.
All right, we better keep track. I forgot my phone at home.
Are you joking?
Yeah. No, I'm not joking. I forgot my phone at home. So I was going to put my timer on and see how long it took us to do one problem. It felt like that was 8 minutes.
I have the timer on my watch. I can do it.
All right, we're going to time us. Questions on the first one. That's example 1. I have 6 examples.
Oh, good.
All right, I gave you 20 tonight for homework. All right. So these are the 3 questions I ever ask when we do something complicated. I say this: are you clueless?
No.
Are you confident?
Yes.
Or are you
Medium.
confident you're going to make a mistake?
Yes.
Which one?
Both.
Yeah.
Right.
I'm confident I'm gonna make
All
a
the
mistake.
above.
For me as a teacher, we got to get past clueless. Like, I'm not doing my job if I have clueless students. But I'm going to claim I'm doing my job if you say you're confident you're going to make mistakes. Confident you make mistakes means you understand where your mistakes might come from.
I don't understand.
Whenever I do decimal multiplication, I am always confident that I will make a mistake. Me, the math teacher. I'm confident I will probably make a mistake, especially if I'm asked to do 20 of them. The chances of me doing all 20 perfectly are probably slim, right? But I am certainly confident that I know what I'm doing, and I also know where my mistakes might come from. I'm also not going to feel crushed when I get some of them wrong. You know, I suck at math, I'm horrible. No,
I will feel like that.
it's a lot of math to do. Going back to the problem, I'm not going to do the actual well, let me see if I can do it. So this was, each number represents one calculation, correct? And the ones that were carried represent 2 calculations. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then you do your adding, 13, 14, 15, 16, 17, 18, with 2 more carries. That's 20. And then you move the decimal place. That was 21 things you had to do in one problem. 21 things, math things you had to do in one problem. If you got one thing wrong out of 21 problems, you would still get an A, correct? You get one thing wrong on this problem, you got the problem wrong. I mean, numerically speaking. So my point being is that this is challenging when to get things accurately for every single one. Do not beat yourself up. If you're getting them all wrong, we do have issues. But if you're getting, I don't know, 2 or 3 of these wrong out of 20, I'm saying you're probably okay. So I at least need to get everyone that you're confident you will make a mistake.
Yes.
Okay. Hopefully half of you are very confident, the other half are confident you'll probably make a mistake or 2.
Wow.
All right. So let's do some more practice.
Started.
All right. This is example number 2, box 3. We got 11.32 times 8.73. My suggestion is to always put the one with the most digits on top. Is that the first one or the second one?
The first one.
Okay, so we put the first one on top, the second one on the bottom. We do not need to line up decimal places. It is convenient, however, to line up digits when it's right justified. The right justified means everything's lined up from right to left. All right, hey, do you know how many lines you get? I'm sorry, how many rows you get?
3.
Well, how do you know it's going to be 3? Because the second number has 3 digits. On the previous problem, we were multiplying something with 2 digits. We had 2 rows right here. Now we're going to multiply something that has 3 digits. It's going to be even worse. We're going to have more calculations. We're going to have 3 rows of things. This is going to be ugly. But we can do this. Same procedure, 3 times. I'm going to do this quickly. Oh, somebody was supposed to be timing me.
I already started.
Okay, thank you. 3 times 2 is 6. I'm going to try to do it in the pace that would take me to write it, okay? I'm not carrying anything. 3 times 3 is 9. I write a 9. I'm doing things nice, neat, and orderly. 3 times 1 is 3. We like ones. 3 times 1 is 3. I'm done with the first row. That was 4 calculations. The second one, I must add 1 0. It's always 1. Not a zero. The number of zeros you add is 1 less than the row that you're on. So the first one, 1 less than 1 is 0, so that's why we didn't have any zeros. But on the second one, 2 minus 1 is 1, so we need to add 1 0. All right, 7 times 2 is 14. I got to carry 1. 7 times 3 is 21, plus 1 is 22. Got to carry 2. Oh, it's getting messy. 7 times 1 is 7, plus 2 is 9. 7 times 1 is 7. I'm not done. I got to deal with the 8 now. That means I'm on my third row. 3 minus 1 is 2. I'm going to add 2 zeros. 2 zeros. On graph paper, things line up nice, neat, and orderly. When you're doing it by hand, if your digits are not, that'll work as well. If your digits are not equally spaced, you can get into problems, especially when there's 3 rows of numbers. All right, let's see. My carry is kind of in the way, so there's the magic of PowerPoint. I make it go away. You're going to be crossing things out, or maybe doing it in a third color. I don't know. 8 times 2 is 16, so 6 carry your 1. 8 times 3 is 24, plus 1 is 25. 5 carry 2. That's 25. 8 times 1 is 8, plus 2 is 10, so 0, carry your 1. 8 times 1 is
9.
It's not 9, but it's 8, plus 1 is, though, 9. Correct. Yes?
I got it right.
Well, we're not done yet.
No, I think I got it right. All this part.
Okay, that's good.
The person who's horrible at
That's good. So we draw a line and we add our columns now. 6 plus a bunch of zeros is 6. 9 plus 4 is 13. I got to carry 1. I got to squeeze that 1 in somewhere. Notice I didn't write my carry. 3 plus 2 is 5. Plus 6 is 11. Plus 1 that I carried that I didn't write the carry is 12. So I put a 2, carry a 1. Apparently I'm being lazy and not writing my carry. And remember, I'm carrying 1 now again. 3 plus 9 is 12, plus 5 is 17, plus 1 is 18. Carrier 1 again. 1 plus 7 is 8. Hand sanitizer. I'm not carrying anything now, and I write a 9. Notice I haven't messed with the decimal at all until the very last step. The last step is we count decimal places. I'm just counting, literally. 1, 2, 3, 4. There are 4 decimal places in total. So I move my decimal place over 4. 1, 2, 3, 4. And I get to my answer, 98.8236. So 98 and 8,236 10,000ths.
Time was 4 minutes.
It took me 4 minutes, and I kind of did that exactly at a pace that a student would be writing would take.
And 22 seconds.
So 4.5 minutes rounding, yeah.
Hey Google, what's 4 times 20?
All right, so 4 times 20 is 80 minutes. So if you are slow at this, it's going to take you some time. Now, granted, they're not all 4 digits times 3 digits. So not all of them will be that slow.
The first 2 problems are 2 digits times 1 digit.
A 2 digits times a 1 digit is less than a minute, right?
And then the third one, and then number 3 is a 3 digit times a 2 digit.
3 digit times 2 digit will take some time, and that's probably 2 to 3 minutes. Okay.
Wait, this doesn't look that hard.
Well, then good.
Well, just look at it though.
Well, I'm giving you worst case. This year and
Yeah.
going forward, we'll be doing problems like this.
You scared me.
Now, granted, right, as we get higher in, like for instance, my geometry students and anyone higher, they use a calculator every day. Like they can, geometry, algebra 2, pre-calculus, calculus, you got a calculator on your desk every day. You're like, well, it's going to be so easy. Yeah, it won't be, right? Because this part is the, oh yeah, whatever, that's the given, right? I know that I can do that. And I have a calculator. We do other things in higher level now. But the world that you exist in right now, this is your world. Decimal multiplication, decimal long division by hand. Okay.
Are some of the problems that you do?
I'm already tired. Now I did 2 problems.
I don't know how we feel at the end
All
of
right.
the day.
Yeah.
Well, technically I did 3 because I showed you 1. All right. Example number 4. We got a 4 digit times a 2 digit. So we're going to have 2 rows. Oh, we like zeros. Why do we like zeros? Why do we like zeros in the number? Why do we like zeros in the number? Go ahead, Elizabeth. Malachi, are you checking your work or are you doing it with the calculator? Okay, that's fine. You are allowed to check, absolutely. Agreed. Right. You're fine. All right. So I'm going to go back to why do we like zeros?
They're fun.
Because they're easy.
Why are they easy?
Because there's nothing more to do for them.
You just put 0 and you're done when you're doing multiplication with 0, right? There's nothing to think about. So some students will even skip that row. Oh, you will get into problems. Because then you'll forget to add how many zeros for your next one. So I would not recommend, unless it's the first digit is a 0, I would not recommend skipping the 0 row. I'll show you what I mean here. All right. So let's see. 2 times 3 is 6. 2 times 0 is 0. I'm not skipping anything. 2 times 2 is 4. 2 times 8 is 6. That was an easy row. We're on the second row. 2 minus 1 is 1, so we need to add 1 0. 3 times 3 is 9. I'm lining everything up. 3 toes, that's zeros. We like zeros. 3 times 0 is 0. 3 times 2 is 6. 3 times 8 is 24. I've got nothing left to do except for adding. There's a bunch of zeros there. It makes our life easy when there's zeros. So I get 6, 9, 4. That's easy. 6 plus 6 is 12. 2 carrier 1. 4 plus 1 is 5 plus the carry. Gives me 6. 4 plus 1 is 5. We were carrying 1 though, so that'll give us 6. And then a 2. We did that pretty quickly. There are 2 decimal places. So we move it over 2 and we're done. Yeah. Yes. Questions? All right. As a class, do I need to do any more examples? I have plenty of them. Do I need to do any more examples?
2 more. No.
All right.
No, please.
I will show you this one. Example 5. Why is this one different?
They're both decimal.
They were all both decimals.
Because it's special.
Why is this one special? Notice on the previous one, the first number had the most digits and the second one the fewest. Now I reversed that. Now the first one has the fewest digits. There's only 2 of them. The second one has 3. So my recommendation is you put the one with the most digits on the top. Okay? If you do it the other way, this one you're going to have 3 rows.
Just add 0.
There's no zeros to add. There'll be 3 rows. I'll do it both ways to show you.
Well, I'm talking about just like when you have 2.3, you have it on the top. Just
Oh, I don't even need to do that.
All
right. I'm just going to write 2.3. Yes.
So, if there's a, you know, like the, yeah, like how many numbers are behind a decimal?
Correct.
There's a 0 and a 3. That counts 2.
You got to point to the problem.
So, this one?
Yeah, you count the 0, not the leading 0.
I know.
Yeah, so 1, 2, 3, 4. There's 4. All right. He was asking if it was 0.03, because it's a 0, do you still count that as a decimal place? You do. All right. So let's see. Let me do this one real quick. 3 times 2 is 6. 3 times 0 is 0. 3 times 1 is 3. Bring down a 0. 2 times 2 is 4. 2 times 0 is 0. 2 times 1 is 2. And we're done. Okay. Now we add 6 and 0 is 6, 4 and 0 is 4, 3 and 0 is 3, and a 2. Now we count decimal places. This was pretty much his question. Does this 0 count? Because it's 0, it does. 1, 2, 3. So we move it over 3 decimal places. Now, look what will happen since it was your question, Caden. If we put 2.3 on the top and 1.02 on the bottom, we better get the same answer. This is what it would look like. 2 times 3. 2 times 2, bring down a 0. 0 times 3, 0. 0 times 2, 0. Now bring down 2 zeros. 1 times 3, 1 times 2, add 6, 4, 3, 2.
You still get the same answer.
You still get the same answer, but you get 3 rows. And one of them is all zeros. It just seems like wasted effort, right?
So why don't you take out the 0?
You can, but my problem is a lot of kids, when they do that, they forget when they get here that they'll be adding 2 zeros, right? They'll ignore this row and they're like, oh, I'm on my second row, so I'm going to add 1 0, and it throws things off. I'm just going to say, if you line up with the one with the most digits put on top, you won't ever make that mistake. All right. Unless the second number does have some zeros in it. You can still make that mistake. I'm tired. You guys want to see some more? Or are you done?
No,
No.
God.
All
I'm
right.
hearing this.
And I got to teach this one more time too.
Oh, I feel so
Actually, this is not too bad. It's the decimal long division that is troublesome.
You're giving us nightmares already.
Well, it's not. It's just
I don't think I can.
multiplication. There's no guessing or anything like that. It's just a straight up algorithm. You follow it, you're there. Decimal long division involves some appropriate guessing sometimes, and then checking to see if your guess was correct. All right. So the rules were you may use a calculator to check your answer, not to do your work. As always, if you are weak with your multiplication skills, you can have a multiplication table in front of you. Always. I'll leave that up to you to make that decision. All right. Who's been working the whole time on their homework? All right. Where are you at? What number?
15.
He's on number 10. You're on number.
9.
You're on number.
18.
You're on number.
13.
You're on number.
17.
So that
On our-
we only have a 50-minute class, and I took 10 minutes of your time to get started. I'm just going to say most of you are going to be done in well under 50 minutes.
Well, I'm on
You're on number 8. Well, you also were paying attention for some of the class. I'm just saying the people that had paid no attention and were working, they're all going to be done in well under, they're probably going to be done in 30 minutes. All right,
That's a
so it's
good
about
guess.
30 minutes worth of work to do 20
Alright,
problems.
Let's place bets on. Let's place bets on.
I'll place bets on who talks the most and gets the least done. I think I will win that.
Ace.
Ace.
It's not here, but it still talks to us.
What's up?
What are we doing? We're done.
Oh, I got somebody's already done.
No, I'm not done yet. I'm close to being done.
Okay, well then, let's see. We got 10 minutes left of class.
Really?
10. So let's see how many people can get done.
I'm not.
And if you need any individual help, absolutely ask. Ask. Everybody feeling confident or confident you're going to make a mistake? I'm confident that I'll probably make a mistake as well too. All right, e-learners, I'm going to stop that right now. They're just going to work to finish their homework right now. If you guys have any questions, make sure you do. Josh, any questions?
Goodbye, Joshua.
Nope. Okay, I'll let you go. Oh, he said no.